Hello and welcome to Buildings of Tomorrow. My name is John Lester, and in today's episode, we are talking about the energy management hierarchy of needs. I'm joined today by James Dice, the master of disaster, the king of Nexus. James, thank you very much for joining us.
Thanks for having me, John. Appreciate it.
It's an absolute pleasure. Let's start with Nexus. Can you give me a quick introduction of what Nexus is, who you are, and what you do to help support us in the industry?
Yeah, thank you. Nexus is a media company, it's a consultancy, and it's now an online school. So we have an online course that's launching this fall. The media part is a newsletter. I send out a weekly newsletter every Tuesday, and a podcast. So podcast every Thursday. And so today's podcast day, and I'm glad to be on the other side of the mic here with you today.
Nice. It's always a nice change to jump onto the other side, isn't it?
Yeah.
Perfect. So for those people out there, head to nexus.substack.com, go and check it out. I subscribe to the newsletter myself. It's a great way to get a couple of insights onto what's new. You have a section about what's on your mind this week and these kinds of things. So good fun, especially for people looking into this world, like the analytics side of the world, smart buildings. How do we create them? How do we enable them? It's a great place to kind of get that overview and get some insight from that perspective. Now today we're talking, or in this episode, we're talking about energy management and the hierarchy of needs. Give us a quick introduction. What do we mean when we talk about this phrase?
Yeah, this concept came from actually one of my readers. So I didn't make up the name, but it's probably not a very well-known name. So we have a lot of buzzwords in our industry. It's not a well-known buzzword. But the hierarchy of needs concept is basically saying, we have all these advanced technologies that can be installed, like AI, machine learning, analytics. You can do all of that to save energy, but there actually probably is a better place to start and a more simple and often cheaper place to start. And that would be more at the base of the hierarchy of needs, the beginning of the hierarchy of needs. It's a play on, obviously, Maslow's hierarchy of needs. But we can jump through the different levels if you'd like. But that's kind of the general concept is let's start with an easier and more digestible place and kind of build up from there. And the beauty of it is the higher levels actually sort of depend on the lower levels. And so if you were to start with higher levels, it actually would inhibit your progress of what you're trying to accomplish.
Right. So it's a way to kind of visualize the fact that, taking these approaches that modern technology enables us for is still a bit of a journey that you kind of have to start with the basics. And if you jump straight to the end, if you start, dealing with some of that really advanced stuff without having your backyard in order, without having the basics well organized, you might actually undermine your ability to achieve your goals. Totally. Perfect. So let's start. When you mentioned the Maslow hierarchy of needs, I imagine the triangle. For those who are just listening and not watching, don't worry. We'll just imagine the triangle as we talk through it, and we'll get there. So let's start at the very bottom. The base, and work our way up. What is at the bottom of that triangle?
Yeah. So the bottom is basically the metering level, right? So you can actually do a ton of cool stuff and drive a lot of energy savings from just using your meter data, whether that be utility bill data, which is obviously the simplest place to start. Every single building has a utility bill, and there are 12 data points per year that provide a lot of good insights on how you're doing compared to other buildings, whether you're saving energy year over year. Those types of things can be just had in a very simple, very cheap, very easy to start sort of way. Mm-hmm. And then a lot of buildings nowadays also have interval meters or smart meters, some people call them, whether they're a sub meter for a tenant in a building or just at the whole building level, or whether they're metering one building as part of a campus. So these meters are popping up more and more. They're actually installed by utilities now as just part of the normal process for metering the building. And so those have 15-minute or hourly data that can be used to create all kinds of really cool analytics, and often done in a very cheap way as well.
Yeah, right. So, at that base level, we're not talking about big investments. We're not talking about new sensors, new hardware, new control systems or anything. We're just talking about leveraging what already exists within the building and actually starting there and using that information effectively without having to expand our horizons to anything overly complex.
Exactly. And with all the complex stuff that we're about to talk about, often this first level is used to measure savings from all the other levels and justify the investment in all the other levels. So it's foundational in that way as well.
Yeah, perfect. So that's the base. Let's move up a level. What's that next step as far as this journey goes?
Yeah, the next level is what I like to call the enablers. So the enablers of energy savings would be your building automation system. So being able to control your building in the right way. The next piece of it would be opening up your data. So if you're going to do things at higher levels like analytics and advanced controls, you need to be able to use your data in a way that allows that. And then the third would be some sort of energy retrofit or retro commissioning project where you're really implementing the things that come out of audits and things like that, where you're able to upgrade systems and really drive big energy savings through projects.
Yeah, right. So this level really starts to bring in those components within a building that can implement the actions and the decisions that you make. And obviously, without that, it's all just information and insights. But without actions, it doesn't really get us to where we need to be.
Yeah, and I think the key thing to point out is that if this level is not done well, then what we're about to talk about next, it's going to make it really, really difficult to see success there.
Yeah, it's almost like I think about muscles and hands. If you don't have the muscles and the hands organized, no matter what the brain thinks, you can't put that into action. And
exactly.
No matter how smart we are, we can't realize that activity. Yeah. Then let's get to the fun stuff, or the more detailed stuff. What comes above that level?
Yeah, so once you have the controls in place and once you have the data freed up to do fun stuff, well, now you can start to talk about analytics, fault detection, diagnostics, predictive maintenance, these sorts of like what we would call buzzwords, like here on the Buildings of Tomorrow podcast, where these are the more interesting and exciting parts of our industry right now, but they're also some of the least understood. But so this is where you're getting into using the data that you've freed up on the level before this, and you're really able to drive huge savings, but not so much drive the savings as maintain them. So in level 2, we did retrofits, we installed controls, we got our programming in order, and we probably created a bunch of savings at that level 2. But level 3 allows you to say, hey, okay, 6 months after that retrofit, how are things operating? And really able to detect when the building starts to drift away.
Right. So that's using that information so that we get consistency, so that we find sustainability in the changes that we make, and also enabling us to react when changes come along. We talked before about you may have metering or interval metering for tenancies and things like this. Tenancies change, space utilization or the way that buildings are used changes. So that kind of information enables us to get insights into how those changes affect our sustainability goals.
Mm-hmm. Exactly.
So I feel like we're getting to the top. And what is on the top of this pyramid that we've built?
Yeah, so I think it's good to pause here and say that if a given building is doing the first 3 levels, they're probably doing really great. They're probably seeing a lot of energy savings. And so even talking about the pinnacle of the pyramid, even talking about it is kind of cutting edge at this point. Yeah. But I like to talk about it because there are several startups and it's becoming more and more the buzzword is popping up with these advanced sort of controls. So I call the pinnacle of the pyramid advanced supervisory control, and it's where you're getting into this AI-based control of the building. So that's really what's next.
And that's when we start to talk about buildings, not just recognizing potential actions, but actually taking those actions itself, making decisions, at least at a basic level, of when there's clear opportunities to make savings or to realize the benefits or the goals that are requested, actually doing that without any human interaction.
Yeah, I think what most people find when they do, say, fault detection or they do analytics, it's a human in the loop sort of tool where it's going to discover some sort of issue and now a human has to take action. And what advanced supervisory control brings to the table is now the system can actually close the loop on its own. Exactly.
Yeah, I like that point because I think a lot of people forget that, when we talk about analytics, and it's something I've talked in the past on this show with different experts, is that just because analytics is leveraging data, just because there are algorithms involved, the expertise of the people in the building, the knowledge, the experience is still required to decide of, that analytics approach can identify 1,000 different things that you can do, but deciding what to do, deciding what's feasible and what's the most impact still comes down to human interaction and that knowledge. So when we go to this next level that you're describing now, it's adding another layer on top of that automation to make some of those decisions without that individual expertise being involved.
Yeah, and I think you're right. There's a lot of skepticism about whether that fourth level is even needed at this point, to be honest. So is the industry ready is a lot of what I hear when I talk about this. And so my opinion is that there's actually two levels of advanced supervisory control. And I know we're going to get into this in a future podcast, but actually supervisory control is part of every building automation system, right? So it's sequences and set points and schedules that are really the core of energy efficiency and the core of running an optimized building. And so that piece really isn't that difficult to kind of wrap your head around. So I would advise people to maybe view it as that more simple definition as just optimizing your 3 S's, your set points, your sequences, and your schedules.
Yeah, right. So it's not completely rocket science. It's not all future. This is something that, when you talk about set points and sequences, this is the core of our industry when we talk about building automation. This is where we started almost. So that those parts of what we do are still essential and already bring us some of that functionality. And now as technology streaks ahead, it opens up new opportunities to perhaps do more and more. Now, this might be a tough question, and feel free to just pass, but how do you think we're doing as an industry? If you looked at those first 3 levels and we talked about analytics and we talked about how we're leveraging data to effectively reach the decisions, the goals that we're trying to make, how are we doing in general from your perspective?
Yeah, so I think, like I said before, if we're doing the first 3 levels, we're actually doing really, really well. Because most of the buildings that I've been in, there's so much opportunity there. There's so much opportunity to optimize those 3 S's. So just within the existing control system, so much to be done. And then even with the 3rd level, with FDD and doing more analytics, that whole side of our industry is yet to scale up. And it's primed and ready, and I think it's proven, but we still have so much more room to grow as far as the adoption of that technology.
Yeah, and what happens, because as you say, we still have a long way to go from the adoption perspective. We haven't really deployed this into our industry in general. If we counted 100 buildings, maybe only one of them would really have this level of control operating at a level that we would consider optimal. Is that the trap for us? What happens if we start there, if we try and jump directly to level 3, we try and get technologies, get solutions, apply them to buildings and don't get our house in order before, we don't put the focus on level 1 and level 2 in preparation for that. Where does that leave us?
Yeah, I think there's a couple. I think if you skip level 1, you're not able to communicate the results. Even if you're successful with the other levels, you're not able to say, hey, we saved X dollars or X kilowatt hours. You're not able to fully understand the impact you've had and therefore not able to report on it. If you skip level 2, it actually makes level 3 and level 4 a lot more expensive as well. So if your controls aren't set up in a way that they're basically able to communicate the data to your FDD platform or your advanced supervisory control platform. And it takes a lot of actually human effort to map that data over and to make it available. So number one, it makes it more expensive. And then number two, when you say you find the analytics system finds a fault, it actually, if you're not set up on that level 2 very well, it actually makes it really difficult to then implement the solution to that fault, right? So what I preach a lot is that in that level 2 is to have, standards for your building automation system, really getting the spec in order to where it really supports those upper levels.
Yeah, perfect. Now you mentioned a few times there FTD. We're talking about fault detection there, and diagnosing those faults. What happens? What's the issue, and why did it happen? As an example. Okay, perfect. Just so we have that clarity, because I think it's an important thing for people to understand that when we talk about fault detection, it sounds like a simple thing, but it's not always. Especially the second D. Finding a fault is one thing, but trying to understand and comparing it to what happened last week, last year, or the last time that it happened, and trying to understand exactly why that happened is a huge step that isn't easily achieved either.
Yeah, and that's where on that level 2, I like to talk also about making the data, sort of freeing it up and making it more available to a fault detection platform. So what goes into that is also like adding context to it. So, what is this discharge air temperature? What does it mean? What air handler is it in? What floor is it on? What building is it in? What VAV box does it connect to? So all of those things make the fault detection happen in a more optimized way. Exactly.
Yeah, absolutely. And that's where we risk to jump. We risk opening the Pandora's box when we start talking about trying to integrate and free up that data. How do we do that? Semantic tagging as a key enabler to enable us to do that in a scalable manner, and then how does the industry do that in a consistent manner, and what happens within the industry to enable us to be vendor agnostic and consistent in that way. Naming conventions change from engineer to engineer, and trying to find our way through that murky world is a battle in itself, I think.
Exactly, and I don't have the answer to fixing that one on this episode.
Yeah, this is a tough one, and maybe that's a good spot. I think very much appreciate your time. So thank you for joining us today for this episode.
Thanks for having me.
Anytime, and I think that's a really good spot for us to stop for this topic as well. You've explained it quite nicely. We might even find ourselves a graphic to go with this topic, so that it's a little bit easier for those who are able to view it, to have a bit of a listen, and understand a little bit clearer. But from my perspective, nice one. Thank you very much. Again, remember, if you're interested in these kinds of topics, if you're in the industry and you want to learn a little bit more, head to nexus.substack.com, subscribe to the newsletter, listen to the podcast. What I like about your podcast is the conversations get really nice and in depth, but you can also get to the start and get a good insight. And you talk to so many different people across the industry with different insights or different perspectives. So that's really good fun. And don't forget the introductory course as well while you're there. And remember to subscribe to us here as well, wherever you're listening to us, whichever channel. Comment, like, share, ask some questions so we can follow up and spend some more time with James and go into a bit more depth in some of those areas that you're interested in. So thank you, and we'll see you again for the next episode.